Hi everyone. Yeah, so this is a continuation of uh, the lecture we had in a previous video. If you notice from that video, you realize that you realize that there was this question we're solving we did not complete. And it's reads. Three consecutive terms of geometric series have product 343 and sum 49/2. Find the numbers, yeah. Three consecutive terms of a geometric series have product 343 and sum 49/2. Find the numbers and went through it to a certain point. We identify the consecutive terms, and then through that we could establish two equations based on the question statement. Now, we had to solve them simultaneously, and we we found, okay, nothing was found actually. Yeah, nothing was found. We had to make A the subject and we substituted A into a different equation, which is equation 2. So nothing was really found. Now, we got to the part where I've ticked with the red ink, and it's a quadratic equation. Typically, quadratic equations, quadratic equations are equations whose highest variable is 2, or the highest degree is 2. So quadratic equations, the highest degree is 2. So when you see any equation with variables and the highest power among the variables is 2, or the highest degree is 2, it's a quadratic equation. So here, what variables do you see in that equation? What variables do you see in that equation? You don't see any variable in the equation I've marked with red. Now, the highest power among those, in fact, it's just a variable. So the highest power on them is 2, exponent 2. So it's a quadratic equation. Once you're able to know this, know that quadratic equation cannot be solved algebraically by just adding and subtracting. So you see 14r minus 35r, 14r squared minus 35r. So you're gonna subtract them. No, it's not done like that. It's not done like that. There is a special way to solve that. I remember back in SS, maybe I was kind of confused. I think in my WASI or one of our mock exam, I ran into something like this and I tried to add them. I tried to add the numbers, but it was just not making any sense. And, n- n- nothing could come to my mind at that point in time that, hey, it's a quadratic equation, and quadratic equations, you don't have to add, you cannot add or subtract them algebraically as we do with other equations. That point in time it didn't come to mind. Yeah, so it's a quadratic equation. We have a special way of solving them. We have a special way of solving them. Yeah, so that special way is what I outlined in our previous lecture. You are either solving them with a formula or you are solving them by factorizing or you are completing the squares or solving them graphically. That I remember every single thing I said in that lecture. I wrote them on the side of the note. Now, the best to go, the best to do right now is to factorize. Now, to factorize, you go to your calculator because we've already gone through series of steps. So you go to your calculator and you put in the values. Yeah, so when you go to your calculator, you press mode. Mode is on the calculator. Then you look for equation, EQN. Equation is number 5. So you press 5. Then 3. 3, it's a quadratic equation. You know, I told you all quadratic equations are represented in this form: ax squared plus bx plus c. So you see x is the variable and the highest is 2. So it's represented there. That's number 3. Now, if you do it well, it will ask you what is a. So a is a coefficient of the variable with the squared. Again, a is the coefficient of the variable of the squared. So a is 14. So you press 14 and you press equal to, it will jump to the next box. B is x. That's after the square, it reduces. It reduces. The square, it reduces. So x, the variable without a power or has a power of 1. Yeah. So it's B. B is a coefficient of what I said earlier. So over here, the B is minus 35. So minus 35. Then you press equal to. Oops. Then it jumps to the next box. C is the constant, the number without a variable. So the constant there is 14. So you press 14. Then you press equal to. You press equal to give you two answers. Quadratic equations have two answers, right? It has two answers. So it's 2 and what? Like 2.5. Now, you can't just write the answers here. As we are marking, we look for steps and we award you marks for steps. You can't just write there. So the answers are the corner, right? So it's 2.5. So I said we have to show as though we are working it out, right? So we are putting them in factors. For factorization, when you go through the long procedure, this is what you get. So we're putting them in factors. So you have R, you start with the variable. Then now, if the calculator give you a positive answer, when you are expressing it in factors, make it negative. So R minus 2. You open another bracket. Of course, it's a positive number, half, right? So you change it to negative. So that's how can you see R minus half. But then I said that factors cannot be expressed in fractions. We don't do that. But I mean, this is a way to remember. So after expressing it in fraction, after writing the fraction in a way you have to, then you remember that we don't express factors in fractions. So move the 2 to be a coefficient of the variable. So the 2 will come here. So you have 2R. You have 2R. So just move the 2R. Yeah. So that is it. That's all. Equals 0. Then now you have the factors. So if you have gone through the long approach, this is going to be the factors. Then now you have R minus 2 is equal to 0. I mean, you now equate each factor to 0. So R here will be what? 2. If you do it well, it will bring the answer back. Here to be 2R. Let me plug out my keyboard. Here too is going to be 2R minus 2R minus 1 equals 0. So you have 2R is equal to what? 1. So 2R is equal to 1. You divide by 2, you divide by 2. That 2, you have R to be equal to what? Half. So you see, you got it back. If you do it well, you get it back. You get it back. You can't just write the answers R equals 2, R equals half. You have to show a step. And anyone doing the factorization approach would have these factors in the bracket. So now that is it. Now we have R. We have R. So we have R. Okay. So we can choose. Oops. Why is no moving? So you can choose any of the R to get A. So you can choose any of the R. Okay. Put the values of R into equation. Which of the equation will be easier? 1 into equation 1. Let me reduce the font here. Into equation 1. Now, equation 1 is A cube R cube equals 343. Now, for R equals 2. So when R is equal to 2, that means that you have A cube R is what? 2 cube is equal to 343. So you have 2 cube is 8. Yeah. A cube is equal to 343. So A cube, if you want to get A cube, 343 over 8. A cube is equal to, well, it cannot be, yeah. I thought the fraction can be reduced, but it cannot be reduced. So A cube will be 343 over what? 8. Then you divide by, no, you take the cube root of A. And you take the cube root of A. This one cancels that. So A is equal to, now, cube root of A, if we do indices, you notice that it's the same as cube root of 343 over cube root of 8. When you have a cube root on a whole fraction, it affects each of them. Cube root of 8 will definitely be 2, but I don't know that for 343. To get cube root on a calculator, there is a square root sign here. On top, you see cube root. On top, you see cube root. So you press shift, then you press that key. If you do it properly, it will bring the cube root feature. Then you put in 343. You can put in the whole fraction. 343.
7 and 2.
In fact, let's put in everything because we did not break it down in a step. So it will be 343 over 8. Over 8, yeah. So it gives you 7 over. No. Let's do it one. So cube root of cube, yeah, the same feature, shift, then that key. So you have cube root. Then you put 343 over, yeah, because everything should be under the cube root over 8. Yeah, you get 7 over 2. So if you're following the solution properly, we had 2 values for R. So if you are choosing, you can choose to use one of them, it's fine. You will still get the consecutive terms right. You get it right. But I want to present all the solution for you to see. So, um, yeah, so we have done the first value for R. Now, for R is equal to 1 over 2. For R equals 1 over 2. The formula is A cube. Sorry, that equation one is A cube R cube equals 343. So you have A cube into bracket 1 over 2 equals 343. So we have A cube over 2 equals 343. 2 times. So you have A cube equals 343 times 2. 343 times 2. 686. So you have A cube is equal to 686. You take the cube root of A. Yet you take the cube root of A. Cube root cancels that. A is equal to cube root. I've already shown you how to do that. So shift and that 686.
8 point.
No, it shouldn't be a decimal.
Oh. So it's a decimal.
A cube, R cube. Alice, it should be a fraction.
It's a decimal.
Let me see what's wrong. Equation 1. Oh. A cube, R cube equals 343. Okay. So I've seen what the problem is. I hope I didn't commit the same mistake here. Yeah. Okay. Yeah, it's A cube R cube equals 343. So if you are saying R is 1 over 2, remember it's R cube. So it's R cube. So that'll be now 1 over 2 cube. The cube will affect the 1. That'll be 1 cube over 1 cube is 1 over 2 cube is 8. So it should have been, so that will be 1 over 8 multiplying A cube, A cube 1 over 8. Visualize this as that, A cube 1 over 8. So if you visualize it at that, now A cube times 1 is A cube. It will only multiply the top, by the way. So it will be A cube over 8. So, yeah, over 8. If you have any question, ask. So that'll be A cube equals 343 times 8. Here you cross multiply. A cube, this is regarded as over 1. So A cube equals 343 times 8. That's 27. Yeah. That's 2744. All right. And you take the cube root. 2744. Okay, now you take cube root. I shown you how to do that. So 2744. That's 14. All right. So you have E, you have R. You can choose your consecutive terms. You have E. Now you can, so you see the values were 2. So if you are using R equals 2, it has its own E. If you are using R equals half, it has its own E. Now, any of this pair will give you the consecutive term, so you can choose which one you like. So someone should use, okay, someone should use the r equals half and a equals 14, and let me use r equals 2 and a equals 7 over 2. Okay, so therefore, the consecutive terms are, so it's a, so 7 over 2. If you remember, the consecutive terms are a, look up a r exponent 2. I'm scrolling up, keep in mind, a r exponent 2, a r exponent 2. So this a r 7 over 2, a, right? R, that r is 2, right? a r. So, and the other one is what? a r, which is 2 exponent 2. You cast your mind back. So that'll be 7 over 2. So 14 over 2. 14 over 2 is something. I think it's 7. So I'm cleaning. It's 7. Yeah. And the next one is, let's see, 2 squared is 4. So that'll be 7 over 2 times 4. 4. It's 14. So that is it. So these are the consecutive terms. If you are using r equals half, a equals 14, your consecutive terms will be 14, comma, that's your a. So 14, a r, that's a r is half. And then the other one will be a r exponent 2, right? So that'll be 14. Half of 14 is 7, comma. Half squared will be 1 over 4. 1 over 4 times 14. Am I correct? Yeah, 1 over 4 times 14. Let's see. Oh, what was I trying to cancel over then? 1 over 4 times 14 is 7 over 2. So you see the consecutive terms are the same. Yeah, they are the same. 14, 7, 7 over 2, 7 over 2, 7, 14. Those are the 3 consecutive terms. What is important is they are consecutive. They follow one another. 7 what over 2. All right. I'll pause for questions. Okay, so this will end today's session. When I meet you again, we'll talk about sum of a geometric sequence and then application of geometric sequence. Yeah. So see you next in our next session.